A few years ago, a friend told me that a battery delivers 200 amps, and I told him that some batteries could deliver more than 400 amps in the first moments. Laughing, he said that this could kill a person, and that he saw it as an inconsistency, because we can touch the battery terminals and nothing happens to us. No harm at all. I told him that it was because the voltage is not sufficient, and he replied that when you start the car, hundreds of amps do flow. I said yes, but the human body has an electrical resistance approximately 4 million times higher than that of the starter motor. Obviously, change in perception of someone who thinks a battery can deliver 200 amps, which for him means it will always deliver 200 amps, is very difficult. All power sources can be limited both in voltage and in current. If a battery has a fixed voltage, the current it delivers depends on the resistance applied as a load. For example, a phone charger rated at 3 amps doesn't deliver 3 amps from start to finish of charging. As the battery approaches 100% charge, the current decreases. When you have breakfast, you eat faster the hungrier you are, regardless of the fact that the amount of food is the same every morning. The smart guys at home might say that touching batteries or cells with your hands does nothing, but that's not true. Something does happen. It's just that the amounts are ridiculously small. So is there danger? No. These amounts are so tiny that it's comparable to decades ago, when people said that if you had appliances in your bedroom, your sleep wouldn't be efficient. I won't argue about that here, but induced currents through electromagnetic waves or through electrostatic discharges, electricity suddenly discharged because tension of thousands of volts has accumulated, are violent and very fast. By the time you pull your hand away from the car door after a static shock, it is already discharged, so it can't hurt you anymore. It's unpleasant, but it can damage electronic circuits, which is why technicians use grounded wrist straps when working. People who know about this might say that what can actually kill you is the current. In other words, the amps. So my friend in principle is right. 200 amps not only have the strength to kill you, but 2,000 people at once. But to get that current, you need either a sufficiently high voltage or sufficiently low resistance. And the human body does not have such low resistance that 200 amps could flow with just 12 volts. So why is static electricity from a car unpleasant but not deadly? Well, first, static electricity can be deadly. A lightning strike can fry you, and that is electrostatic. But the amount of coulombs a car can accumulate under normal conditions is not dangerous. The voltage may be between 2,000 and 10,000 volts, but I don't think it exceeds 10 microcoulombs. So yes, those thousands of volts are unpleasant, but the discharge lasts less than a millisecond. In fact, electric fly swatters work at those same voltages, but their capacitor capacity is 10 times greater than that of a car, enough to kill a mosquito. All this is considering that we're talking about thousands of volts and milliseconds. Our body has an electrical resistance between 1 million ohms and 300 ohms, 1 million on the surface of dry skin and 300 in internal organs. If I measure my own resistance on any given day, I get around 250,000 ohms. For reference, this value is measured by my multimeter applying 1 volt to my body. A healthy car battery is between 12.2 volts and 12.8 volts. In my case, it's at 13 volts because I just turned the car off and it stayed there, but little by little it will go down. I use an analog ammeter because it's faster than a digital one at showing fluctuations. On the 50 microamp scale, depending on the contact surface and the pressure I apply, about 50 microamps flow. Then I switch to the digital meter, so you can see the numbers. 50 microamps is 0.05 milliamps, or 0.00005 amps. In a previous video I tested, and found that at 1 milliamp I could feel discomfort. That means that if 0.05 milliamps flow here with 12.9 volts, I would need 20 times more current to feel uncomfortable. So, can I be a conductor? Can I charge another battery using my arms as cables like in fake videos? No. In fact, with 260,000 ohms, I don't see myself as a conductor. Besides, you'd need another person for the other cable, because with just one hand you close the circuit without letting positive and negative flow back and forth. And if I put my hand as resistance on a battery, could I discharge it? Yes, but don't expect my body to light up or heat up. At 12.93 V and 0.00005 amps, I consume 0.64 milliwatts from a battery. So here, I am literally an electronic resistor of almost 270K. I could joke with a friend by resting my hand on his battery to drain it, but it would take a very long time. If the battery is 56 amp hours, I'd have to stay 896,000 hours with my hand stuck to battery. That's 37,333 days, or 102 years. And that won't happen because the battery will degrade long before it can be drained through my hands. Can I put my hand to measure the volts as if it were a potentiometer? The problem is that the skin acts the same on both sides. So even if I place a millimeter from the terminal, it will still show almost 12 V. The probes of my multimeter are like needles. If I stick them into my fingers, I can lower my body resistance to less than 100,000 ohms. Here I am with my 24V battery, which is now at its maximum value of 29.2 V. We can see that 113 microamps flow, that is 0.113 milliamps. My resistance does not vary much from 12 to 30 volts.
Ahora voy a mojarme los brazos, mójame así, para luego para hacer la prueba de la corriente, a ver si de verdad humedecido. Espérate, si quieres me quito la camiseta. Hombre, pero espérate que...
With a moist body, my resistance does not change because in reality the water only helps with the connection, like increasing the cross-section of conductor. For example, when they use to wet the heads of those condemned to the electric chair, what water does is improve the contact between the source and a larger part of the skin by making it moist, which is like increasing the cross-sectional area of a conductor cable. But the body's internal resistance does not vary significantly with the same voltages. If the voltage increases, water allows better contact with the body, and the body's resistance decreases. The human body is not a constant electrical resistance. It varies with many factors. In the next video, we will look at the test screwdriver, the touch buttons of new elevators, and other things.